Hello class, I'm going to go through Volcanoes Lab number 1 and explain some of the figures and the instructions that might be confusing. Note that this is not a substitution for reading all the instructions yourselves. You definitely have to do that, but some of the figures might be a little bit confusing, so I'm going to go over that. So this question here, you have a series of questions asking you for the repose time of a volcano in years. The repose time is the number of years between eruptions. So to answer the question how long is the repose time, you'd figure out the number of years between 1883 and 1812, and that's what the repose time would be. So when you find like the periods between each of these different dates, you get a repose time, and you can take the average of those to use as a prediction of when the volcano will erupt again. There's a question that has a lot of maps showing pyroclastic flow deposits. It's going to ask you to use some satellite and aerial photos to annotate this map here to show where the edges of these pyroclastic flow deposits are. So you have this image. It shows you pyroclastic flow deposits in 1963. This is the light gray versus vegetation, which is the dark gray. And then, so you can see like this is the border of the pyroclastic flow deposits in that year. And later in 1976, the border changed again. Here's vegetation, here's pyroclastic flow deposits. You draw the border right around here. And you're going to have to transfer those borders to this map right here. So one thing to note is that this map is turned on its side relative to these photos. So when you're doing your annotation, you're going to want to rotate this thing so that this little caption here is on the bottom. So there's another series of questions that asks you to calculate the amount of time it would take for a tsunami to go from Augustine Volcano to Homer Spit. And the information you need for that is the distances between these sections here, the depths of the water, and then you can use that to calculate the speed of the waves and add those time periods together. So this gives you the depths right here. So this section is going to be 30 meters deep, this is 70 meters deep, this is 30 meters deep. And you're also going to have to get the scale from this. So one of the questions asks you to measure how many centimeters there are on the scale bar. And that's going to vary depending on the screen of your laptop, but you're going to use that information to calculate these distances in kilometers after you measure them in centimeters. There's a series of questions that asks about ash clouds coming from Augustine Volcano. It shows you this map. This map is kind of hard to read, but Augustine Volcano is right here. There's Talkeetna, Valdez, Anchorage, Kenai, Homer, Seward. Fairbanks is up here somewhere. And you also get the information, some information about wind directions in Kodiak. So Kodiak is right here. So say there's a weather station in Kodiak that gives you wind directions. There isn't one on Augustine Volcano. at least for this question. So you kind of have to assume that the wind patterns in Kodiak are similar to what's going on in Augustine Volcano. So these show the wind directions for the different seasons in Kodiak. This pie piece here, it's really big, so it shows that most of the wind comes from the west and goes east, but it can also come from the southwest and go northeast, and it's similar for all the seasons. So you can tell that the wind direction from Augustine Volcano can come from west and go east, or it can come from southwest and go northeast, or it could come from northwest and go southeast. You also get to look at some thin sections of some volcanic rock that was spewed out of a volcano, and we assume that the content of the rock is similar to the contents of the ash particles. So you're going to have to look at each of these little particles. These would represent ash particles, and try to decide how big they are. You get a scale down here. This is 1 millimeter right here. And obviously this little thing here is way smaller than 1 millimeter. So you kind of have to eyeball this and divide it into 10. So here's 1/10 of a millimeter here. And then if you wanted to go even smaller, you could say that this is 1/10 of 1/10 of a millimeter, which is about as wide as the tail of this arrow. So you can kind of see like, okay, this is 1/10 of 1/10 of a millimeter here. And there's some questions that ask you about which minerals are in the ash, and it tells you right on this picture. So I think normally it would ask you to actually identify the minerals, but we identified them for you, so don't worry about that. And then one of the questions asks about what happens to the ash when it goes through a jet engine and what it does to the outside of a plane. So you have all these minerals that are in the ash, and it tells you the hardness of the mineral and the melting point. So this hardness, it's quantified using the Mohs hardness scale. So the higher the number, the harder a substance is. So quartz is harder than plagioclase, so quartz could scratch plagioclase. And aluminum has a hardness of 2 or 3, so you can imagine what something with a hardness of 6 could do to aluminum. Then it also shows you the melting point. So you're going to be asking yourself, can a jet engine melt plagioclase? Can it melt quartz? Can it melt magnetite? And what happens if it melts these minerals that are in the ash that are going through the engine? So as always, make sure you read the instructions carefully. If you have any questions, please let me know on chat or email me. And good luck with the lab. Hope you enjoy it.